So we want to get into the math of this. We've got a couple of classes here, so we'll take our time to make sure we really understand this. But it starts back with this idea of intrinsic value versus time value. So an option price, that $14 I showed you for Apple, or $15 I guess now for Apple. So the 285 on Apple, it's I switched the dates here. So this is December 18th, 2020. So that 2770, that is the option premium. All right, so we're gonna Apple 28 strike. The call premium is 2770. And where does our stock price close? At 268.37. 268. Let's just round it to 268. All right, so there's a formula we're going to be using. I'm going to use it over and over and over and over again. There's two of them. There's one for calls and one for puts. So we're working with calls right now, so I'm going to show you the call. And it says the intrinsic value of a call option equals the max of S minus X and 0. So if this is a negative number, you use 0, minus the price of the call. So right now we're going to leave out. So this first part of this equation is the value of intrinsic value. So what we're going to be doing later when we do this analysis is we're going to take the intrinsic value of a call, which is the first part of this formula, minus what we pay for the call, and that's going to tell us our gain or loss on the call. So the intrinsic value of the call is S minus X, comma 0. All right, so here we have the max of what S is 268, the strike is 280, comma 0. What is that going to be? That's going to be 0. If the stock is trading less than the strike, the option has no intrinsic value. Now we know that the option price equals the intrinsic value plus the time value. Another way to say this is that time value equals the option price or option premium minus the intrinsic value. So in this case, the option price is $27.70. The intrinsic value is 0, so the time value of this option is going to be $27.70. So this is very, very important. All options that are, see if you can think, maybe you have to freeze the video and just think through this. All options that are out of the money. Remember, for calls, that means that the stock price is worth less than the strike. That's what we had here. The stock was 268 and the strike was 280. For puts, that's when the strike is less than the stock price. If they're out of the money, then the option premium is 100% time value. It's all time value. So when we talk about time decay, you can see this 280 strike call because it's out of the money, because the Apple is trading for 268, so it's out of the money. So 100% of this option is time value. All right, let's try a second one. Let's do Apple with a 250 strike. Or let's make it a little more interesting. Let's make it 265 strike. All right. The call premium. So we can go back and look at look at 265. Let's hopefully they have a 265. They don't have a 265, so we'll have to do a 260. That was the problem with me going out so far into the future. So with a 260 strike, the call premium is $37. All right, and the stock price is still, we're going to say 268. I am rounding, so rounding's okay. So we already know, you know, that this is in the money. So if it's in the money, the intrinsic value is going to be different. So we have to know what the intrinsic value is first. So we already know that intrinsic value equals a max of the strike minus, the stock price minus the strike price, and 0. In this case, it's the max of, here the stock price is 268, the strike price is 260, and 0. So that intrinsic value is $8. So what is the time value? Well, the time value is going to equal the option price, which we said was 37, minus the intrinsic value, and that's going to give us 29. So the time value for this particular security is $29. It's not that far away from the time value of the one that's out of the money. So its time value is $29. The time value here is $27.70, and that could partially be because there's a dividend coming up. And remember, the dividend is definitely going to affect you, especially if you're in the money. So there may be already an adjustment for that. But anyway, so the time value is a little bit more, and I'm not sure about the dividend side, but they should be similar. We're essentially, and plus, remember, we were rounding, so if we take the rounding out, that might get us closer. So let's actually even do that. See how much closer that gets us. So we're talking about 28.37. So let's get precise here. 28.37. That doesn't change the intrinsic value up here. I mean, the time value here is still 27.70. So here, if we do 2068.37, that gives us 37 cents. So we get 37 minus 8.37. That gives us 8. Man, don't hold me on this. 863 maybe. 2863. So real close. So I apologize if my math is wrong here. So yeah, that gives you 29 minus 37 cents. So that should be 28.63. So you can see the time values are very, very similar. The option prices are very, very different. One option is trading for 37. The other one is trading for 27.7. Why are they so different? Well, because this option has $8.37 of time value. I mean, of intrinsic value, excuse me, of intrinsic value. So that intrinsic value would make it higher. So that's what we're talking about here with time value versus intrinsic value. So I'll highlight because I think that's in the notes. All right, so everything we're going to do the rest of these classes when we look at options is we'll be using this formula over and over again, the intrinsic value formula. All we have to do at the end is subtract what we paid for the option, and that'll tell us the gain or loss on the option. Because, and the reason we're doing that, so the intrinsic value, we're going to expiration. We're going to go to expiration and look at these. At expiration, the option value will equal the intrinsic value. And why is that? Because at expiration, what is the time value? Time value, by definition, must be 0. Because there's no time left. So there can't be any time value left. So at expiration, the options value will be the intrinsic value. All you got to do is subtract what you pay for that option. And so I just want to, I'm introducing it. We're going to be doing this over and over and over again. So if it's not clear to you right now, trust me, it will get clear as we get into these. So what we're going to do is we're going to build an Excel spreadsheet. I'm going to set up an Excel spreadsheet, and we're going to price buying a call. That's what it means to be long a call option. We're going to buy a call. We're going to buy a put. That means going long a put option. And we're going to look at other combinations. We can combine calls and puts. We can combine long and short positions. We can mix different strikes. We can mix maturity dates. Probably most important is sometimes we'll own the underlying security and sometimes we won't. So what I want to introduce to you right now, and we'll come back to this, I'm actually going to try to test this in a future class if I can find an option. It's kind of tough to do because I need an at-the-money option. That's hard to find sometimes. But this concept of put-call parity. So I want you to actually, you might even put this video on pause. Sorry, and just type in put-call parity. And go on to Wikipedia. Wikipedia does a good job with this. Put-call parity is one of my favorite theories in finance. It's pretty amazing. This is the way I'm used to seeing it expressed, so I'll bring this into our notes. Oops. Sorry, I don't know what I just did. So I don't know, it won't let me copy image. That's what I want to do. I'll bring out notes. I think I have it here in the notes already, but anyway, just to show you what Wikipedia has. So it didn't work. All right, so forget that. So let me do it as a snip because I want you to see that what I'm showing you is not radically different than what's in Wikipedia. So sorry, I'm just having trouble getting it to work out. Someone's out there going, wow, Professor Sweet, if you would just do this, everything would work out. But I obviously hit the wrong button. All right, so put-call parity. It says C plus DK equals P plus S. What in the world does that mean? Well, the C and the P and the S we've already used. C means the value of a call option equals, the P is the value of a put option, plus S, that's the value of the stock. So C plus some weird thing equals P plus S. All right, what is this DK? Well, we already know what K is. Remember, I don't use K, I use X. So what this DK is the present value of the strike price. So whatever interest rates are, if the strike price is $100, you will essentially make an investment at, say, $98, so that expiration, it will mature at $100. So essentially, that's a risk-free bond that matures exactly at the strike price. And so what put-call parity is telling you, if you own a call plus you own a bond whose maturity value exactly at expiration, exactly the strike price of the option, that will equal, I don't say it should equal, most of the time it equals, should be close. No, it should equal out to the penny exactly the price of a put plus the current price of the stock. All right, so I'm going to do my best. We won't do it in this session, but at the beginning of the next session or something, I'm going to try to find an option that's trading right near the money, right at the money as much as I can. You can see with the Apple option, Apple's trading at 268. There are no options out there with a strike of 268.37. The best I can probably do is 265 or 270. So I need to find. It's getting closer. It's trading at 269.70 now. I need to find a stock that's trading right at an option strike price, and then I can show you the math here. So it's a little tough for me to show you. So what that means is, if the value of this is different than the value of that, then you have an arbitrage opportunity. So what does arbitrage mean? So you should look up arbitrage in Wikipedia as well. Arbitrage, trade, Wikipedia. And what is arbitrage? So to me, arbitrage is something that costs you nothing today, but in the future is going to have an assured positive return. So you pay $0 today, and in 1 year it pays you $6. How many of those transactions would you do? Well, I would do 1 trillion of those. If it cost me 0 today and I'm sure to get $6 per transaction in a year, I would do 1 trillion of those. That's called arbitrage. No cost. It's not even risk-free. It's more than risk-free, but it is risk-free It has to be risk-free to be true arbitrage, but no risk. But it costs you nothing, and you have a gain at the end. And so there's a lot of theories here, and you can actually go through this. It'd be a really good one to read. Some of this would be over my head because there's some pretty advanced math in this stuff. I can't talk to you about spatial arbitrage. I did, as working with a life insurance company, they did talk a lot about arbitrage-free pricing for bonds. I can tell you I understood at the time it was shown to me, but it was an incredibly complex concept. John Toohey was teaching our fixed income class. He's going to teach an investment class like this. He would be an expert in that because he was an actuary, life actuary. They know this stuff. The actuarial exams are quite advanced on these type of concepts. We in finance should probably be learning this type of stuff. This is really, really important when we talk about things like mortgage-backed securities and other complex bond securities. But if we look at this, we can move these things around. That means a call should be the exact same thing. Owning a call should be the exact same thing as owning a put plus owning the stock minus borrowing money, that the repayment on the debt would be exactly the strike price of the option. So we're talking two options, a call option and a put option. They have the exact same strike price, which happens to equal the stock price. So we have an at-the-money option. And a stock, if you wanted to buy the stock, you could, instead of buying the stock, you could sell a put option, buy a call option, and buy a bond that expires at the value of the strike price. And that would give you the exact same thing as buying the stock. And you can see the other combinations out there. So what does that mean then? Let's say the call has a premium of $20. Let's say the put is trading for $22. Let's say the stock is trading for $150. And let's say the bond, you could borrow money, and that would be $149. I don't know if I did all that right, but we'll see. So we're saying that $20 should equal $22 plus $150 minus $149. Is that true? What is $172 minus $149? No, you got $20 equals $23. That doesn't work out, right? The 22, 172, let's make sure. So I said plus 22 plus 149, plus 150 minus 149. That equals 23. Just to make sure, I don't want someone coming back later and saying, wow, that's really confusing. They don't equal. If they don't equal, what do? Therefore, you buy the call, you short the put, you short the stock, and you buy the bond. And if you do that, you have something that will give you $3 today, right? Because this will cost you $20. This will give you $23. So if you do that, you'll end up getting $3 today, and you know at expiration, with absolute certainty, at expiration, both sides will be exactly equal. You know at expiration that this will equal that at expiration. Therefore, they should equal each other today. And if they don't, you're getting $3 a day for something you know will be worth $0 in the future. How many transactions of that would you do? I would do 1 trillion if they would let me. 1 trillion times $3, that's $3 trillion that I know when this thing expires will be worth $0. Now, can you find one of these? I'll try to find one and show you the math. I might be a little bit off on the interest rate. These things are usually priced off of LIBOR, and I'll have to get the right rate. I can probably get it pretty close. The times where I've been able to show it, I've gotten it very, very, very close. But it all comes down to me being able to find a stock that can actually that's actually trading correctly. We also have the issue of bid-ask, and so I'll have to talk about bid-ask as well. We'll get into that when we get into examples. All right, so that's it for this class. And so what we're going to be doing in future classes is we're going to work through these different examples. It will take us a few sessions to do this. I'll do it slowly. I'll try to talk slowly. I'll be doing it in Excel, so I strongly recommend next class that you have Excel open, and I'll show I'm going to be pulling real life prices. We're not going to be making this stuff up. I'll use real life prices, and I'm going to show you exactly how this is done.